In this final video for Chapter 0, so to speak, we'll be talking about absolute value inequalities. So first off, how do we solve absolute value inequalities? Well, we're always going to break them up. Namely, here, in doing so, we understand that the absolute value of u being less than or equal to a number, and here a needs to be a positive number for this to make any sense, or it could be 0, means that negative a, u must be between negative a and positive a. In a similar way, absolute value of u strictly less than a means u must be strictly between negative a and a. Now, it gets a little bit harder to talk about, and you can't really write as a double inequality when you try to write absolute value of u is strictly greater than a. Because what that actually means is u is either greater than a or u is less than negative a. Over here, and similarly in with the last one, the absolute value is greater than or equal to a means that u is greater than or equal to a or u is less than or equal to negative a. Now, these may seem unintuitive, but if you remember that absolute value is the distance from 0, this actually makes a lot of sense. So here, again, please note that only if a is greater than or equal to 0 do these really make any sense, okay? But as I was saying, what we can do is we can think about this in terms of distance. So for instance, if we were to try to talk about this inequality, what would we be saying? Well, we would be saying that the distance between the distance that u is from 0 is at most a away. Well, it could go this direction, but it could also go in the negative direction distance-wise. So, in a similar way, if you want to try to think about the distance here in this inequality, you would have that the distance that u is the distance that u is from 0 is at its closest is at a. Well, that means that at the closest it's either at a or it's at negative a, but it can't get any closer than that because of this inequality on the distance. So using that understanding of how to break up inequalities, we can go ahead and solve each of these. So let me go ahead and have this. And so, what does this look like? Well, here, breaking this one up, we have that x minus 5 would be either less than 2 or it's greater than negative 2. Now we just go through and solve this like we did any other double inequality. So add 5 to all sides. You get 3, you get x, and you get 7. And adding and subtracting preserves the inequality. And so this is actually our solution set. That is what we actually, or if you prefer, in interval notation, it's the interval 3 to 7. What does that look like as a solution set? Well, what it looks like is, if this is, let's call this 5, 6, 7, 4, 3, 2, so that would be 8. So if this is 3, what we have is that we're between 3 and 7, but we're not touching them, and we go in between them. Now, what about over here? Over here, if we break up the inequality, we have that either x plus 3 is greater than or equal to 7, or x plus 3 is less than or equal to negative 7. Well, breaking it up that way, we now have that x, if we subtract 3 from both sides, we have that x is greater than or equal to 4, or x is less than or equal to, adding 3 to both sides, negative 4. Subtracting 3 from both sides, sorry, so negative 10. I was wondering why they were both 4. However, how would we write that in interval notation? Well, we have to use a special symbol here called a union. Namely, here if we wrote this interval Well, first let's start on this side because I like to go from left to right. So starting at infinity, we could be all the way out at negative infinity. Starting off there, then we go all the way up till we get to negative 10. And we could include that, right? Again, the interval helps see this. So here, if this is negative 10, then we know that we could be less than that, right? Or equal to it, hence the shading in. However, we could also be greater than 4, greater than or equal to 4. So we shade it in again at 4, and then we go all the way up here. Well, because we could be in either of these, we use a special symbol here called a union symbol. Okay? Now the union symbol does not have a tail. And so just take special note of that. It's a very special symbol because of that. When you're entering your answers into WebAssign, what you can do is if you just type union, this symbol will come up. Anyways, so we're greater than 4, greater than or equal to 4, so that means we're going to go all the way out to infinity, like so. Now let's have you try an example. So go ahead and try solving the absolute value of x minus 20 is less than or equal to 4, and graph the solution set. On the count of 3, I'll reveal the solution. 1, 2, 3. So again, our first step is that we break up the inequality into the 2 different inequalities. Here we can write as a double inequality, which is nice because then we can just go through and solve it. Once we have the solution, or if you prefer an interval notation, this is the solution set. For more practice in linear and working with absolute value inequalities, be sure to see page A64 of the textbook and try working numbers 4 and 43 through 58. In our next video, we'll start talking about the Cartesian plane and graphing.